Okay, so in today's class, we're going to look at determinants and a process of solving systems of equations called Cramer's rule. So we've already learned how to use matrices to solve systems of equations. One technique we learned was the row echelon form. And then we learned the other one was the reduced row echelon. And so we're going to add another method to our toolbox of how to solve systems of equations. And that's going to be Cramer's rule. But Cramer's rule involves a value that's called the determinant. And so that's the first thing that we have to learn. We have to learn is what is a determinant. Basically, a determinant is a special number that to talk about any square matrix. Now, what's a square matrix? Exactly. So if I hear that, a square matrix is any matrix that has the same number of rows as it does columns. So you can only find the determinant of 2x2s, 3x3s, 9x9s, those types. Only square matrices can you find the determinant of. And the determinant is a single value. And how you find a determinant of a 2x2 matrix is really easy. Okay, so here we're going to find our first determinant. Now, when I'm talking about finding the determinant here, first let's talk about some notations. One notation for determinant is DET, and then let's say this is matrix A. So DET of matrix A, you might see it written like this. That's how the calculator uses it. You might see it written as find the determinant of matrix A. So this would be A. Another notation that means the same thing. This is what textbooks use, and this is what I will use, because it's not the calculator notation. This is the original notation before calculators. Is if I wanted you to find the determinant of matrix A here, that would be the determinant of matrix A. So putting the name of the matrix inside the what looks sort of like absolute values. So I could basically what we're doing here to find the determinant of matrix A, we're finding the determinant of 5, 2, negative 6, 3. So we write it like this. So that's our determinant notation. To find the determinant, you're going to do diagonal down minus diagonal up. So what I'm going to do is I'm going to take this diagonal here, and I'm going to find the product of that diagonal. So I'm going to multiply everything on the diagonal together. So my term is going to be equal to 5 times 3. So that's diagonal down minus diagonal up. And so diagonal up is going to be negative 6 times 2. So diagonal down, the product of the diagonal of every numbers on the diagonal down minus the product of all of the numbers on the diagonal up. So that will give us 15, and then negative 6 times 2 is negative 12 times a negative becomes positive 12. So 15 plus 12 gives us 27. So that is our determinant. The determinant is 27. So that is how you find a determinant of a 2x2 matrix. The product of all the numbers on the diagonal down minus the product of the numbers on the diagonal up. Okay, for a 3x3 matrix, there is a, we're going to do pretty much the same thing. There's actually a couple techniques of doing this. I like the method I'm about to teach you because it's still diagonals down minus diagonals up. So it kind of uses the same format. Teacher Watt likes another very common method where you rewrite this as different square matrices of 2x2 matrices. And then you find the determinants of those different 2x2 matrices. If you're curious about that technique, I included that video of how to do it in that method on Canvas on our Determinants and Cramer's Rule page. So I highly suggest you watch it because it is very interesting to see how you do it. I like doing this method because I think it takes up less room and it gives you the same pattern of diagonals down minus diagonals up. All right, so I'm going to find the determinant of this matrix. It's a 3x3, and this technique will work for 3 by 3s, 5 by 5s, 9 by 9s. It continues on. Basically what you want to do, so I'm going to find my diagonals here, my determinants. I want to find the determinant of 0, 2, 1. Write that 2 better. 3, negative 1, 1, 4, 0, 1. I'm going to find the determinants of this. But we have to find, now before, when we did that one diagonal down, that was all my diagonals down, but I have more rows going on here. So to fix this problem, the first thing you're going to do is you're going to recopy the first 2 columns. 0, 3, 4, 2, negative 1, 0. So I just recopy my first and my second row. Okay. I'm going to take my diagonal down. So 0 times a negative 1 times 1. What's 0 times negative 1 times 1? 0. Okay, so that's 0. Now, plus, this is where it's different, plus the next diagonal down. Okay, so now I'm going to take 2 times 1 times 4, which is 8. So I'm going to add 8 here, plus my next diagonal down. And then I get to the end of the determinant, so I'll be done. So I got to do this next diagonal down. So 1 times 3 times 0, which is 0. So I take the sum of all the diagonals down. So that's the difference here. Sum of the diagonals down minus the sum of the diagonals up. So my diagonals up would be here. 4 times negative 1 times 1. What would that give us? Negative 4. Plus my next diagonal up, 0 times 1 times 0. That's 0. Plus my next diagonal up, 1 times 3 times 2, which is 6. So sum of the diagonals down minus the sum of the diagonals up. So let's do those sums. 0 plus 8 plus 0, 8. Minus, and then this sum here, negative 4 plus 0 plus 6, 2. And then 8 plus 2, 8 minus 2, sorry, 8 minus 2 is 6. So the determinant of this 3 by 3 matrix is the number 6. Questions over that? So those are the ones that we're going to focus on, 2 by 2s and 3 by 3s. You can expand this off if you want to do more, but that's all you're going to be required to do in this class. So open up your quiz assignment, determinants and Cramer's rule, and complete the first 1 through 8. Oh, and in case I give you a problem where I have you find the determinant of matrix A times matrix B, order of operations matter. So first thing you have to do is you have to multiply A times B first and get that answer. And then that answer matrix is the one you do the determinant to. So not the determinant separately and then multiply together. Because this is not necessarily equal to the determinant matrix A times the determinant matrix B. You have to do what's inside first. So do multiplication first, and then find the determinant. So there's a couple that has you do things like that. And remember, of our multiplication, we did matrix multiplication. Order did matter. So AB is not the same as BA. So make sure you're reading it closely. Okay, so if the problem asks you to find the determinant, just like you just did in these 8 problems 1 through 8, either a 2 by 2 or 3 by 3 matrix, I want you to show all that work just like what we talked about. Now, for some of these other applications, you're still going to have to find the determinant each time, but I'm going to allow you to use some of your skills on your calculator to do this. So let's talk about how to, I I'm going to talk about how to do this 3x3 matrix here that we just worked by hand on your calculator, so that now you'll have some calculator skills to help you out. And then I'll talk about what work needs to be shown on these other problems that we'll be doing. So here we have this determinant 0, 2, 1, 3, -1, 1, 4, 0, 1. And we're going to do this on our graphing calculator. So let me share the graphing calculator. All right, so we're going to type this into our graphing calculator. So you're going to go first to matrices. If you remember that second -1, that's our matrix thing. And I need to edit my matrix A. So I'm going to cursor over to edit matrix A and push enter. Now that determinant that we ended with was a 3x3 matrix. So I'm going to do 3x3. So enter, enter. And then the matrix was 0, 2, 1, -3. Oh, no, sorry, 3, positive 3. 3, -1. Whoops. -1. Enter. 1. Enter. Then we had 4. Enter. 0. Enter. 1. Okay, so double check. 0, 2, 1, 3, -1, 1, 4, 0, 1. Okay, so you add your matrix into matrix A, and then you quit that screen. So second mode gets us back to our home screen. Now I want to find the determinant of this matrix. So I'm going to go back to my matrix menu, but this time I'm going to cursor over to the math. And DET, the very first option, that's our determinant. Remember that calculator notation for determinant? So it's already highlighted, so I'm going to push enter. Now I need to tell it which matrix to find the determinant of. That's matrix A, so I'm going to go back to my matrix menu. Names A, enter. Close parentheses, enter. There's that 6 that we found when we did it before. Okay, so that's how you can find determinants using your calculator. So put in the matrix and then go to math under the matrix menu and DET, determinants. Okay, stop sharing this. Go back to our work. All right, now there are many, try that again, this one. There are many applications of matrices and determinants. In fact, linear algebra does a lot of this if you ever take that course. But we're going to talk about a few. And this next one we're going to talk about is another way to solve systems of equation. And this is called Cramer's rule. So to solve systems of equation by Cramer's rule, we're going to be using determinants. And I'm going to use some new notations here. So let me introduce some notations I'll be using. When you see D, a big D, this stands for the determinant of just the coefficient matrix. And when you watch Teacher Watch's video and he explains this, this is what he calls the original matrix. Okay, so determinant of the coefficient matrix. And then you'll see D of X, D sub X. This is going to be the determinant of the new matrix we make up. We'll replace all the X coefficients with the answer coefficients. So this stands for finding the determinant of where you substitute in your answer in place of all the X coefficients. And as I work through the example, this might make more sense as I do through it. And D of Y will be similar, the same thing. It's the determinant of when you replace the answer in place of the Y coefficients. And then once we figured that out, here's what Cramer's rule says. For a 2 by 2 matrix or a system of equation with two variables and two equations with two unknowns, to find x, you will take d sub x divided by d. That'll give you your answer to x. To find y, you take d of y divided by d. Okay, so you just kind of got to memorize that pattern there. All right, so let's find these. To set this up, first thing you need to do is you need to figure out what your determinant of your coefficients matrix is. So I'm going to call this matrix D, or determinant D. And that's going to be equal to, and these are your coefficient matrix. So I'm going to take the coefficients of each of these and just write them down. First row is going to be my first equation. Second row is going to be my second equation. First column is all my x's. Second column is all my y's. So this is going to be 12, 3, 2, negative 3. There's my D. 12, 3, 2, negative 3. Okay, now use that new skill I just taught you. Find the determinant of D. So try that in your calculator. See if you can figure out your determinant of D. Anybody get it yet? Negative 42 is correct. So that's negative 42. Okay. Now I'm going to find and set up d sub x. Okay. D sub x says I look back at this red matrix, but in place of every one of these x's, which is this right here, I'm going to plug in my answers. So my first column is now 15 and 13. My second column is still my y's, so that doesn't change. So I just replace, because this one says in place of, you put the answer in place of the x coefficients. So I have 15, 3, 13, negative 3, and then I define the determinant of that. Negative what? Negative 84. Then we're going to have to set up d sub y. D sub y says I go back to my original D matrix, D determinant, and I replace the y's this time. So x is still 12 and 2. I replace the y's with my answers. So that's going to be 15 and then 13. So that's going to be the matrix I set up. What was that? And that gives us 126. Okay, so I need to see this work. I need to see that you set up those determinants, but you're allowed to use your calculator to actually calculate those determinants. Okay, on this type of problem. All right, last thing to do is now we just have to plug in Cramer's rule. We got all the data now, we just plug in Cramer's rule. So x is equal to d sub x, which I'm going to plug in as negative 84. Over d, which is negative 42. I need to see this on your paper as well. And so x becomes 2. Y is d sub y, which is 126, divided by d, which is negative 42. So y is equal to negative 3. Now, often, remember when we did solve systems of equations, it's the point where the two lines intersect each other. So we will usually write our answer in this form. So therefore, our solution is the point 2, negative 3. So sometimes you'll see it like x equals, y equals, but often it'll be the point in which they intersect. Okay, questions over that? All right, I'm going to set up the next one, then I'm going to have you actually solve it. I'll pause and give you a moment to solve it. Okay, this time it's a 3 by 3 matrix. The Cramer's rule is the same. If I wanted to find the x value, it's going to be d sub x over d. To find the y, d sub y over d. And to find the z, it's going to be d sub z over d. Okay, the setup is the same. I need to figure out what the determinant is of my coefficients. So first x coefficients of my first equation is 1, 1, negative 1. Coefficient of the second equation is 3, negative 2, 1. Coefficients of the third equation is 1, 3, negative 2. And then I'll do my calculator to help me. Then I need to find d sub x. Tell me what this matrix would be. What would be the first row of this matrix? 6. Okay, first column then. 6, negative 5, 14. Second column.
1, negative 2, 3.
And last column.
Negative 2.
Okay, so you're going to do that. Okay, what about these of d of y? What would be its setup? What's our first column?
1, 3, 1, 6, negative 5.
So 1, 3, 1. What was the second column?
6, negative 5, 14.
Very good. The answer 6, negative 5, and 14. And then the last one?
Negative 1, 1, 2.
Okay, negative 1, 1, and negative 2. And then the last one, which is new, we haven't done yet, d sub z, but you can probably figure out how that's set up. We're just going to replace the z coefficients with the answer this time. So first column,
1,
1, 3, 1. Second column,
1, negative 2, 3.
1, negative 2, 3. And last column,
6, negative
6, negative 5, and 14. Okay, then I'll give you a moment to use your calculator to find all of those determinants and then plug in this formulas to get your answers using Cramer's rule. Okay, so what was the determinant for D? Negative 3. Very good. Determinant for D sub x? It was also negative 3. Yeah. Determinant of D sub y? Negative 9. And the determinant of D sub z? Positive 6. Okay, so everybody okay with those three? Oh, 4, sorry. Okay, so now I'm ready to get my answers. So to find x, I take d sub x divided by x. So what's d sub x?
1.
So it's negative 3
divided by negative 3.
divided by negative 3 equals 1. Okay, so y, d sub y, negative 9 divided by d, which is negative 3. 3. Okay. Guess I can box these in so I don't lose them. To find z, take d of z, which is 6, divided by d, which is negative 3, equals negative 2. Notice the work I show. I need to see that fraction. Don't go straight to the answer. I want to see that fraction of where you take the d of z over z. I want to see that fraction on the work. You don't have to show this fraction, but you do have to show this one. Okay, before you simplify it down. How would I write this as a point? Oh, so a three-dimensional point has an x, y, and a z. So my answer would be 1, 3, negative 2. Okay, so that's how we can solve system equations using Cramer's rule. Go ahead and work through number 14. Okay, so for our last section, we're going to look at another application of determinant. And determinants also allow us to find the area of a triangle. If the corners of the triangle are given as vertices or coordinate pairs. So if you can plot the triangle on a axis, on a XY axis, a coordinate plane, and you can identify your vertices that, you can find the area of that triangle. So the formula we're going to find for area is going to be equal to area equals. Now, is area positive or negative? What do we always know about area? Positive. Area is always positive. So we're going to use our determinant here, but our determinants sometimes are negative and sometimes are positive. So to fix that in this formula, we take plus or minus 1/2 times this determinant we're going to set up. So if the determinant answer that we set up is a negative, we will multiply by a negative 1/2 so I can get a positive final answer. If the determinant I set up here gives me a positive number, I will multiply by the positive 1/2 so I can get a positive value. So that plus or minus 1/2 helps us determine that value, determine if we're going to get a positive in this determinant or a negative in this determinant. That's all that plus or minus means. Now, to sum up our determinant, well, I have my first point, which is 1, 0. So I can put in my x column 1 and my y column 0. My next equation is 2, 2. So my x column, I can put 2. My y column, I can put 2. And my third point is 4, 3. So my x, I can put 4. And my y, I can put in 3. But something's wrong. Can I find the determinant of that matrix? Why not? It is not a square matrix. We can only find determinants of square matrix. So to fix this problem, with a lot of different math in the background to figure out how this works out, they came up with we can put in these placeholders of 1. So your last column is going to be all 1s. And that's just so we can get that 3x3 matrix that we need to do this. Okay, so I need to take the determinant of this 3x3 matrix. I'm going to do this the old-fashioned way since I don't have a calculator up here with me right now. So I'm going to take my diagonals down. So 1 times 2 times 1, what's that? That gives us a 2 plus my next diagonal down, 0 times 1 times 4, which is 0. And then my next diagonal down, 1 times 2 times 3, which is 6. Minus my diagonals up. So that's going to be 4 times 2 times 1, which is 8. Plus my next diagonals down, up, which is 3 times 1 times 1, which is 3. I guess I should switch over colors here. Plus my next diagonal up, 1 times 2 times 0, which is 0. Okay, so area is equal to plus or minus 1/2. 2 plus 0 plus 6, that's 8. Minus 8 plus 3 is 11. So 8 minus 11, negative 3. Stay down, stay down. No, it's not going down at all. Okay. So I get negative 3. So should I multiply by negative 1/2 or the positive 1/2? Negative 1/2. So I can get a positive answer. So A is equal to 3/2. And since this is area, whatever that unit of measurement is, squared. So unit squared. And that is it. That's our area formula. So plus or minus 1/2 of the determinants made by the three vertices, plus that kind of fill in the blank, that placeholder of 1s in your last column. All right, I might ask this slightly different. I gave you almost 3 points, 2.5 points, and I want to figure out what value of y here will give us an area of 6 square units. So we just already know has changed slightly. So now I know my area is 6. and that's equal to plus or minus. And what would be my first column, my first row, so across, the first row of this determinant matrix? So -2, -3, then placeholder of 1. Okay, second row, 1, -1, and then placeholder 1. And then the last row, -8, y, and placeholder of the 1. Okay, so we're going to set that up. Now this one you have to do by hand because you can't set it up in your calculator. Calculator can't solve for the y. Put the x variable in there. It will give you something else, but it's whatever you solve. Whatever x was the last time you solved for x in your calculator. So we don't want to do that. So we're going to do this one by hand. So 6 is equal to plus or minus 1/2. Okay, and then let's do diagonals down. So let me put in my numbers first. So -2, 1, -8, -3, -1, y. Diagonals down is -2 times -1 times 1. So what's that? That's just 2. Plus, next diagonal down, -3 times 1 times -8. Positive 24. Plus, next diagonal down, 1 times 1 times y is y. Minus, diagonals up, -8 times -1 times 1 gives us a positive 8. Plus the next diagonal up, oops, not Cramer, y plus 1 plus -2. That's a -2y. Plus 1 times 1 times -3. That gives us a -3. So we got 6 plus or minus 1/2. Okay, that's a 26 plus y. And this gives us 5 minus 2y, but distributing that negative, so it's going to be -5 plus 2y. Why won't this work with me today? Ugh. All right, there it goes. Oh. 6 equals plus or minus. So 6 is equal to plus or minus 1/2. That's 21 plus 3y. Now, you can distribute that 1/2 if you want, but I got plus or minus there. So I find it easier at this point, if to figure this out, I'm going to do dividing by plus or minus 1/2, which is the same as multiplying by 2. So that becomes plus or minus 12 equals that 21 plus 3y. It's a little bit easier to solve this equation. Now I'm going to subtract the 21. And then I'm going to divide by 3. And so I get 2 equations coming out of this. Y is equal to -21 plus 12 divided by 3. So -21 plus 12 divided by 3. What does that give us? 3. Positive or negative? Negative. And then I have -21 minus 12 divided by 3. So that's a -39 divided by 33 divided by 3. So that's -11. So this gives us 2 answers. We will have an area of 6 if y is at -3 or if y is at -11. So there's 2 possibilities. Now, what if I had, so we have like 3 points like this, any 3 non-collinear points form a triangle. Now, what if I move this point, smushed it in, so it forms this nice line? What would the area of that triangle, that smushed triangle be? So if I had points like this and I took this point and I smushed it in, so it just forms a straight line, what would the area be? 0. Because it's linear, it's only one dimensional. There's no area. So area is 0. What do we call it when 3 points are in a straight line? What are they called? What's that name? Let's remember our geometry. Collinear. On the same line. So collinear. So this is going to be using the same thing. So this is saying, I want to determine if these 3 points are collinear. Well, they're collinear if my area is 0. But the only way I can have something plus or minus 1/2 times my sum value is if and that's going to have to equal 0. The only way that can equal 0 is if this right here is equal to 0. That's the only way I can multiply by 1/2 to get 0. Is that what I'm multiplying by has to be 1/2. So for a collinear, what I'm going to do is I'm going to set up the determinant just like we just did. So that's going to be -2, -2, placeholder of 1, 1, 1, 1, 7, 5, 1. But if this gives me an answer of 0, it's collinear. If it gives me an answer of anything besides 0, they are not collinear. So that's our last thing that we're going to check. So we can actually check to figure out if it's collinear. So again, I'll just do this one by hand. I don't want you to get too addicted to your calculator. Let's do a slightly different colors. Okay, so what is my -2 times 1 times 1? That's -2 plus -2 times 1 times 7. That's -14 plus 1 times 1 times 5. 5 minus, we'll go up with blue. So 7 times 1 times 1. That's 7 plus 5 times 1 times -2. That's -10 plus 1 times 1 times -2. That is -2. All right, so let's see. That's -16 plus 5, which would give us okay. And then here we have 7 minus 10, which is -3, minus 2, which is -5, which becomes positive. So that's -6. Are these 3 points collinear? No, because this is not 0, therefore the points are not collinear. And that's because our determinant here was not equal to 0. Name of 0. Okay, so that's the end of it. So now you can finish up the rest of the worksheet.